exercise 4C question 1. Okay, so this is going to combine all our skills together from our partial fractions and our binomial expansion. These are pretty typical exam questions. So let's have a go and see where we get on. So first things first, partial fractions. So they've warmed us up gently with a nice basic 2 linear brackets on the bottom. So if we split that up, it will be a over 1 minus x and b over 2 plus x, like that. Okay, so let's multiply through by the denominator. So that's 8x plus 4, and I'm going to take those two brackets and I'm going to times them up. Okay, so the 1 minus x will cancel with the a to leave the 2 plus x. And then b times 1 minus x, 2 plus x. The 2 plus x will cancel, and I will get left with simply, I lost my pen, 1 minus x. Okay, I'm going to go for the standard technique of chucking an x value in. I'm going to start with x equals minus 2 to eliminate the a term. So minus 16 plus 4 is minus 12. The a term has vanished, and I will get 1 minus 2 is 3, so 3b. So b equals minus 4. Do the same thing again, but this time put in a value of 1. That will give me 12 equals 3a. The b will disappear, so a equals 4. Now, what is nice to do is to go back. Okay, it says express it in partial fractions. So if you take those two and you put them back where they came from, I've got 4 over 1 minus x. And I have got, sorry, minus, let's just correct that. Minus 4 over 2 plus x. Now that minus there could go in the middle, or you could keep it as a plus and put minus 4 on top of the fraction. Either is fine. Okay, so we've done part A, hence or otherwise expand up to x squared. So they've been reasonably nice there. Some will be less nice and make you go to x cubed. So you do not ever want to expand that initial fraction. So this one here. Never expand that, because that would be 8x plus 4 times 1 minus x to the minus 1 times 2 plus x to the minus 1. Perfectly doable, but you'd be there for an hour, and the chance of making a mistake would be huge. Whereas if I go with this side, or more particularly this one, actually all I've got to do is write that one in index form. So that would be 4 lots of 1 minus x to the minus 1 minus 4 lots of 2 plus x to the minus 1. Now, I've still got to do my expansions for the two brackets, but then all I have to do is multiply them by 4 and take them away from each other. Okay, and that's a lot easier than multiplying out 3 long brackets. So always work with partial fractions whenever you're being asked to expand. Now, I'm going to do this clearly and logically. I'm going to do it in colour, because I can. I'm going to start with 1 minus x to the minus 1. I'll deal with the 4s afterwards. Just remember they're there. So if we remember our expansion rules, is it a 1 in the first position? Yes, it is. I can't remember my colouring now. I think I had green for the power, that's minus 1, and red for the x. So this is minus x in this case. So remember our rule, it's 1 plus n x. You could instantly simplify that to plus x if you want, plus n minus 1 over 2 factorial, or just 2, minus x squared. Now remember, it's really important to put whatever your x is, minus x, plus x, 2x, 1x, x over 2, into that bracket, because it all needs to be squared. Now, the great thing about this one is it's the nicest one of all. I love minus 1 powers, because you get that cancels with that, and you just get left with the 1. So I've got 1 plus x squared. It was a nice and easy one, because everything cancels out. So that was my blue expansion, even though I didn't do it all in blue. to the second one. So I've got 2 plus x to the minus 1. Quick look. Is it a 1 in the leading position? No, it's not. So they're making us work a little bit harder on this one. I'm going to have to factorize out that 2. Remember, it has to keep the power. And then I've got 1 plus x over 2 to the minus 1. Okay, so I now have a 1 in the leading position. My x will be x over 2, and my power will be minus 1. So I've got 2 to the minus 1 is a half. Now I'm going to keep that in. I think it's important not to make that appear and disappear, because you're likely to get some issues with error carried forward and also forget to put it back. So I'm going to keep that half there. So I've got 1 plus nx plus minus 1, and we're going to have that same cancellation, x over 2 squared, which will give me a half. If I multiply it in, I've had minus half, so that's going to be minus x over 4. And then I'm going to have that all cancelling. I've got x over 2 squared, so that's x squared over 4 times it by 2. Gives me x squared over 8. Now what we've got to do is take my 2 expansions and put them back in. So my answer will be 4 lots of the 1 plus x squared minus 4 lots of the half minus x over 4 plus x squared over 8. That is important while you're doing this working to keep it as clearly laid out as you can. In the exam, this might be an all-in-one question. It might be split into a couple. They might not even tell you to do the partial fractions at first. So it's knowing that skill set. So think about what we're using and why we're using it. As you can see, that's literally just a nice piece of mental arithmetic. I'm going to get 2 plus 5x plus 7 over 2x squared. Now we're asked for what it's valid for. So if I go back up and have a look, let's have a look first at my blue one, the 1 minus x. So remember, the rule for the validity is the modulus of whatever you're using for x. Now I was using minus x, but going into a modulus, that actually doesn't have any impact, because a modulus means the size of the answer without the sign, the absolute value of it. Now, if I look at my black expansion, because we did use 2 expansions, that one is valid for x over 2, because that's what I used for x, is less than 1, which is modulus of x is less than 2. Now, I've got 2 valid for here, and now I have to think which one is the one I want. Now, I used both expansions, so both must be true. So I like to think of this as which one is stricter. Okay, so in other words, which one will work for both? Right, let's pick a value. The modulus of x is less than 2. So if I said 1.5, does that work in the modulus of x is less than 1? No. Okay, so that isn't always true. Whereas if I pick any value where the modulus of x is less than 1, say a half or minus a half, is it also less than 2? Yes, it is. So the modulus of x is less than 1 applies and works for both expansions. So my answer to finish is for part C, the modulus of x is less than 1. Okay, now if you're doing that in the exam, you may show that or with an and. You could officially use that, but what you need to do is make it clear that that is your answer. Don't just list both of them, because only one of them is true. Okay, so just be careful to show the full valid for, which is less than 1. Okay.